Okay, so for our lesson today, we're going to be continuing with our normal distribution. So again, our normal distribution is a symmetric unimodal distribution. So that happens when majority of our data points fall right in the middle at the same point where we have our mean. So if you look below here, you'll notice that at this bump where the highest frequency of our data points are, we also have this line which represents the mean. And our normal distributions can be really squished together or they can be really far apart. They are all still normal distributions. Now there's two links here for you to take a look at. The first one here just provides some additional information on our normal distribution. So it's a lot of things that we've already talked about, but might just be written in a bit of a different way. So if you need some additional resources and you want to go through and read things in more detail, highly recommended that you click this first link. We've talked about all of this stuff, but it can absolutely make things a little bit clearer for you. Now, before we get to the second one, I just want to briefly recap what yesterday's lesson was all about, and then we'll talk about that second link. So yesterday, we talked about our normal distribution and how our data points are spread out within a normal distribution. So when we have a normal distribution question, we draw our curve and then we mark where our mean is. Now our mean is always going to be right here in the middle. Then what we'll do is we will mark our first interval. Now this interval here is plus or minus 1 standard deviation from the mean. So on the left-hand side, we have our mean minus 1 standard deviation. And on our right-hand side, we have our mean plus 1 standard deviation. Now within there, we have 68% of our data. Now because it's symmetric, we can split this up like that. And that's what yesterday's class was all about. Then once I found that first interval, I would find my second interval. So 2 standard deviations away from the mean. So my mean minus 2 standard deviations and my mean plus 2 standard deviations. Finally, we have this third little interval, which to be honest, we don't use too often because usually at this point our numbers are too small, but we'll include it here just so that we can have it for consistency. So we have our mean minus 3 standard deviations and then our mean plus 3 standard deviations. Now what we did yesterday is we would go through and we would write out all of our percents in those different intervals. Then we would find the range that we're looking for and add up all of the percents. But what happens if my range or the data points I'm looking at aren't exactly 1 standard deviation away or exactly 2 standard deviations away? What if they fall here, for example, half a standard deviation away? Or maybe it's over here, 1.6 standard deviations away. We need to have a method for determining our percent of points that would be less than that or our probability of having a value less than that. So that's what this lesson's all about. So what we do first is we're going to be finding some z-scores. And we're going to go through and standardize this. And I'll get to that second link in a moment where I can show you what this standardizing does. So when we're talking about our normal distribution, we talk about these intervals or how far a data point is away from the mean in terms of standard deviations. The reason why we do this is so that we can compare different normal distributions, and it makes it so that any information that has been determined about a normal distribution that we can use. Anytime we're looking at percents about normal distributions and all this work that has been gathered about the normal distribution, we have to make sure our data is in terms of standard deviations. So that's really important for us to do. and I'll show you what that means later on. Now, let's go back to this second link here. Basically what this does is this is showing us the percentage of points that are in the highlighted regions. So if I am 1 standard deviation from the mean, you'll notice, I'll try to get it exact. You'll notice that we're pretty close to 34, right? And that's exactly what we did yesterday. When we had 1 standard deviation from the mean, we had 34% of our data points. Now, the nice thing about this link in this table here is it can give us some values that aren't directly on 1 standard deviation, 2 standard deviations, and it gives us some of these middle points here. And that's what today's lesson is all about. What if my number I'm looking for is not right on one of our interval points? So we'll go back over here and we'll get into a little bit of background about our normal distribution. Now, this part here is not going to be on an assessment. You don't need to know it. It's just some additional information for you to see, just so that it can help you understand really what's going on. So don't stress about this. It is very overwhelming and a lot going on, but you don't need to know this part here. We're just going to quickly talk about it so you have the background. So to write my normal distribution as a function, I can write it as this function right here. In other words, if I put this into Desmos and I graph it, I will get my normal distribution curve. Now, what we can also do is we can standardize it by using our z-scores. In other words, writing our data point instead of just how far away it is from the mean, we want to write it in terms of standard deviations from the mean. And so once I do that, I get this formula here. Same thing, as long as I know my value of my standard deviation and my mean, I can absolutely find this. Again, if I were to graph it, put it into Desmos, I would get my nice bell curve for my normal distribution. So that's what all of that is about. Now, this is out of the scope of our class, but it is useful to know that there is a function associated with this. Now, anytime I'm finding a probability with a continuous distribution, I need to find the area under the curve for the range I'm looking for. Now, as you could imagine, this is a pretty complex formula, and our curve is also a really funny shape. It's not a shape that we have an equation for to find the area. Now, you certainly could use first-year calculus to figure this out, but it gets very, very complex very, very fast. And our normal distribution is used so frequently that to do these really intense calculations all the time is really inefficient. So what's happened is statisticians have put together what's called a z-score table. And basically what that is it's a table that's done all these area calculations for you already. So it's already found all of our probabilities. So the trick is we just need to know how to use this table, and then we can find any probability that we want. Now, the table can be found under our normal distribution lesson on Classroom. It looks like this. There's 2 pages to it. One is for positive z-scores, so when my data point is above the mean, and the other one is for negative z-scores when my data point is below the mean. Now, I've just copied and pasted them here into Notability, just so I can write on them. But definitely make sure you have them on hand, ready to go and look at. Now, you can absolutely reference these on an assessment. There's no way you ever would need to memorize these. And in the real world, you would always just look it up. So you can absolutely have these with you on any sort of assessment. Now, I'll show you how this all works and how we actually find these probabilities now. So this part can get a little bit confusing. So bear with me as we go through and ask lots and lots of questions if you have them. So here's our question, and our question's actually going to look very similar to some of the questions that we had yesterday. So a normal distribution has a mean of 29 and a standard deviation of 3. What percentage of the data is less than 25? So this is very, very similar to our questions from yesterday. So we'll start by just drawing our normal distribution curve. So I'll just draw my line and I'll draw my curve like that. There we go. Okay, so just like yesterday, I'm going to start by marking my mean. And there's my mean at 29. Now, just for our purposes while we're learning, I'm going to write out all of the different intervals. Later on, once you become comfortable with things, you don't need to do all of these steps, but I just want to show you everything to make sure things are really clear. So I'm going to go through and write out all my intervals. So first, 1 standard deviation away from the mean on either side. So my standard deviation is 3. So 1 standard deviation above the mean, 29 plus 3 is 32. And 1 standard deviation below the mean, 29 minus 3, is going to give us 26. There we go. Going to do the same thing for my next interval. So this one will be 2 standard deviations above the mean. Mean plus 2 standard deviations. My mean minus 2 standard deviations. So at this point, we're approaching things exactly like we did yesterday. So 32 plus 3, which is our standard deviation, is 35, and 26 minus 3 is 23. Okay, so for this particular question, we want to determine the percentage of the data that's less than 25. So if I look at my numbers at the bottom, I have 23, 26, 29, 32, 35. We're looking for 25, and 25 isn't there. So this point is the difference between our questions yesterday and our questions today. So I'm going to mark where 25 is-ish. It's not perfect, but to give us a better idea. So what I'm looking for is my percentage of points that are less than 25. Now, what we would have done yesterday is this would have been on one of my lines perfectly, and then I would have counted up what percentage of points are in each interval, and I would have added those all together. Unfortunately here, we're not landing on an exact interval line, so we can't do that. But people have already determined the percentage of points in this highlighted area based off of my z-score, and that's what my chart is all about. So when we're looking at those percentages, we're always looking at 1 standard deviation from the mean, 2 standard deviations from the mean, etc. So what we need to do is we need to determine how far the point 25 is from the mean. So the first thing that we're going to do is we're going to find our z-score. That's the first thing we have to do. In other words, figure out how many standard deviations away from the mean is this point. So my z-score formula, you'll be given this on the quiz, but just so we remember, it's our data point minus our mean divided by our standard deviation. So our data point is 25 minus our mean, which is 29, divided by our standard deviation, which is 3. Now I can put this into my calculator and I will get negative 1.33. Now what this number means is that the data point 25 is 1.33 standard deviations below the mean. The reason I know it's below the mean is from my graph, of course, but also because the z-score is negative. Now, if I look at my graph, my 25 is definitely more than 1 standard deviation away, but it's not quite 2 standard deviations away. So a z-score of negative 1.33 makes logical sense. Now what I'm going to do is I'm going to use the chart to find our percent / our probability. So sometimes we'll be talking about this in terms of our percentage of points that are below or within a certain range. And sometimes they may ask you about the probability. We can use these numbers for both. So to do this, this is how I write it out. I'm looking for the percentage of points that are less than 25. Now, what I've had to do here is I've had to standardize it so that we're talking about the data in terms of standard deviations away from the mean. So I now have a z-score. So because I've switched it to a z-score, I can rewrite my data point being less than 25 to my z-score being less than 1.33. In other words, what we're saying is what percent of points, or what is the probability that a point is more than 1.33 standard deviations below the mean. That's what this says here. So what we do is we use our z-score chart. And I just have a picture of it right here for us to reference. Now this chart can look a little overwhelming at first, but once we practice with it, we will be absolutely okay. Now what this chart represents is it represents the percentage of points lower than a given score. So once we find this, it will give us the percentage of points that are lower than 25. So let's find it. So first, we look at the first 2 digits of our z-score. In this case, it's negative 1.3. So I go down the first blue column to negative 1.3. Then I need to find the third number. So I'm looking for the hundredths column, and our last number is 3. So that means we're looking in this column right here. So now what I like to do is I'm just going to go down here and here until they meet. And they meet at 0.0918. Now this lesson is a tricky one to do online because what I would have done in person is I would have had our giant z-score table projected onto the screen. And what I would have done is I would have put my one finger on the 0.03 and my other finger on the negative 1.3, and I would have gone like this until my fingers touched. Now, if you have a hard copy of this, you can absolutely still do it, but hopefully this is pretty clear. It's the best way I can think of doing it while we're working with it on this platform, and hopefully it's clear. So what that number means, 0.0918, that means that 9.18% of my points are below this line. And that makes logical sense. It makes sense because we know that below our green line, there was 2.5%. So it has to be bigger than 2.5, but it also needs to be smaller than what we would have at this point, which is 16. So it does make logical sense where we got this number. Now, how we write out a therefore statement or our conclusion for a question like this is we would say, therefore, 9.18% of the data points are less than 25. And that's our final answer. Are there any questions before we move on to the next example? So next example is very similar, just adding kind of one extra layer of difficulty. But are there any questions at all? We're okay? All right. So we'll do one more example and I'll walk through it nice and slow. And then we'll do the first question from the homework too, because I just really want to emphasize how to do this stuff. So I'm just going to make this a little bit smaller just so we have room below to do the next example. Okay, so this next example is going to use the exact same situation as above here. So I'm just going to copy our graph so we can use it again. There we go. Perfect. Okay. Oops, not what I wanted to do. Sorry about that. Okay, so here's our graph again. This time around, we want to determine what percentage of the data is between 24 and 34. So I'm just going to mark those on our graph. So between 24 and 34. Now again, unfortunately, these points don't line up right on our intervals, or else we could have just counted the percents and added them up, and that would have been way nicer. But unfortunately, they're not. And we're looking for the percent of data points that are in between here. So that's what we're trying to figure out. Okay. So unfortunately, because these don't land right on intervals, the first thing we're going to have to do is we're going to have to find z-scores. And the reason we have to do that is we need to determine how far away these data points are from the mean in terms of standard deviations. So we can't just say, okay, that one is 5 points away from the mean. We can't say that. We want to say it in terms of standard deviations. So the first thing that we're going to do is we're going to find our z-scores. That's the very first thing that we're going to do. So we'll do that for 24 first. So our z-score for 24. To find a z-score, we take our data point, we minus the mean, and we divide by the standard deviation. Again, you will be given this formula, but just so that we're consistently practicing with the same thing, I'd like to write it out. So we have 24 minus our mean, which is 29, divided by our standard deviation, which was 3. And that mean and standard deviation I just got from above in the original question. So that will give us 24 minus 29 divided by 3 is negative 1.67. Now this makes sense for a few reasons. Firstly, 24 is below the mean, so it makes sense that our z-score is negative. And it's also bigger than 1 standard deviation away from the mean, so it's more than 1 standard deviation away, but not quite 2. So it does make logical sense. Now we also need to find the z-score for 34 as well. So our z-score is our data point minus our mean divided by our standard deviation. So 34 is our data point here, minus 29 divided by 3. And that will give us 1.67. Now, when we are working with a range, It won't always be like this where I have negative 1.67 and 1.67. It just works out that way. But the steps that we'll use to determine our percentage of points in this range will be the same each time. Okay. So that is our next step. So now that we've done that, we can use our chart to find our percent or probabilities. That's the next thing that we can do. So what we're looking for here is we're looking for the percent of points that are less than 24, or sorry, are greater than 24, but less than 34. That's what we're looking for. Now we have standardized this and written everything in terms of z-scores. So we can rewrite this as our lower z-score, X, and then our higher z-score here, just like that. Now, how do I find this for a range? On our graphs here, on our charts, it doesn't say anything about a range. How do I find that? Now, this is where understanding what the chart means is very, very important. So when I find the value in my chart for 24, so when I look up negative 1.67 in the chart, what that number will give me is the percentage of points below 24. That is the value that is given in the chart. Similarly, when I look up 1.67, so the z-score for 34, it will give me the percentage of points that are below 34. That's what it always gives, is all of the points below. So one thing to note is that we're expecting the percentage of points that are all below 24 is much larger than the amount of points below 24. Now, those are the pieces of information I can get from this chart. How do I just find the middle bit here? That's all I want. I just want the middle bit. So what I want to do is I want to take this whole area for the 34. So I want to take all of the points that are below 34, and then I want to subtract this part because I just want the pink area. Now this part here is all of the points less than 24. So that's what we'll have to do. We'll have to do some subtraction. So what happens is my percentage of points. Oops, this should have been a Z, I apologize. Less than 1.67, and we're going to subtract the percentage of points less than negative 1.67. So let's find some values here. We'll start with the first one with positive 1.67. So we have to go to our positive z-score chart over here. And we start by finding the first two digits. So I go to 1.6, which is down here. There we go. And then what I'm going to do, oops, sorry. There we go. There's my 1.6. Perfect. Then I need to find that third digit, which is 7. So I find 7 here, and then I go to find where these two cross. There we go. And we'll get 0.9525. This means that 95.25 of my points are less than 34. That's what that means. Now we need to find the other one, so negative 1.67. So for this one, we go to my negative z-score chart, and all of these are on the same document on Google Classroom for you. And then I go to negative 1.6 and then 7. And I find where the two connect, and I'll get 0.0475. So what this means is that 4.75% of the data points are less than 24. That's what that means. So now I can just subtract those. And we'll get 0.95. Oh, sorry, 0.905. Wrote that down wrong. So what that means is that is this middle bit here. So what I could write is therefore 90.5% of the points are between 24 and 34. And that's what that means. So these can be a little overwhelming at first, but the more you practice them, the easier and easier it gets. So I'll give everybody a moment to finish writing that down. And then what we're going to do is we are going to do the first question that is for homework. And we'll do that one together because I think everyone could probably use one more example that's written in a bit of a different way. I think it's really worthwhile. So I'll give everybody a moment to quickly write that down. And then we'll get started. Okay. I just want to make sure everybody's written everything down before we get started. Okay. So we'll do the first one from the homework. So I'll give everybody a second to write this down if you want to. This is the first one from the homework, which, oops, sorry, which is on page 430. So this is page 430, number 2. And we will go through that one really quickly, and then we will be done. So I'll give everybody a brief moment to write it down, and then we will get started on this last example. And then I just have a little piece of our z-score chart here, just so that we can use it and I don't have to keep flipping back and forth. All right. So here's our last question that we'll do today. So Michael is 190 centimeters tall. In his high school, the heights are normally distributed with a mean of 165 centimeters and a standard deviation of 20 centimeters. What is the probability that Michael's best friend is shorter than he is? So the first thing that I'm going to do is I'm going to draw my normal distribution. So these are going to be your steps for all of your questions. So the first thing I'm going to do is draw my normal distribution. like that. And then I'm just going to mark out the intervals. Now, once you get comfortable with this stuff, you may not need to mark out all the intervals, but this is a really good method for when you're learning. So my mean is 165 centimeters. Then my first interval, so my mean minus 1 standard deviation. So my standard deviation is 20. So 145. My mean plus 1 standard deviation, 185, like that. Then my next interval, my mean minus 2 standard deviations is 125. And my mean plus 2 standard deviations is 205. Now, Michael is 190 centimeters tall. So we're looking right here. And we want to determine the probability that another student is shorter than Michael, or that their height is less than Michael. So we're looking for this area under the curve here. This is what we're looking for. Now, unfortunately, 190 isn't one of our nice points. So unfortunately, we're not being asked about 125, 145, 165, 185, or 205. But that's okay. We can still figure this out using our z-scores. So the first thing I do is I find my z-score. That's the first thing that I do. So my z-score is my data point minus my mean all over my standard deviation. So I'll have 190 minus 165 all over 20. And that will give us 190 minus 165 divided by 20 is 1.25. There we go. And so now I'm going to use my chart to find that value. So I'm looking for the probability that a student's height is less than 190. I already standardized it. So instead of using X's, I switched everything to z-scores. And the z-score of 190 is 1.25. So it's 1.25 standard deviations above the mean. And now to find this, I use my chart. So I start by looking for the first 2 digits. And those are right here. And then I look at the third digit, which is right here. So I look down here and down here. And I have 0.8944. So what that means is therefore there is an 89.44% chance that his friend is shorter. And that's it.